Hello class! Today I'm going to do some more science. So a couple of weeks ago we did a science experiment about basalt rock and chalk. We looked at which one was porous and which one was non-porous. I'm going to look at rocks again. I'm going to look at basalt and chalk. There's some basalt, same piece actually. There's some basalt from a volcano, and we're going to look at chalk. And we're going to look at how acids affect different rocks in different ways. So for this experiment I've got a few different samples. I've got some shells from some sea creatures, sort of thing that you'd find at the beach. I've got some chalk. This is natural chalk. Maybe not the same thing as what you'd buy in a shop to draw with, but you can use it to write. That's natural chalk. And I've got this piece of basalt, a volcanic piece of rock. Okay, so this is the acid I'm going to be using. It's called hydrochloric acid. But all you need to know is that it's a very strong chemical. It's very powerful. It will hurt your skin if you touch it. This acid will. That's why I'm wearing these rubber gloves. That's why I was wearing goggles to protect my eyes. There are some weak acids that you already know. You know vinegar and lemon juice, orange juice. They are all very acid. They are very acid to taste, but they're not strong, so they won't hurt you. This is super strong and will hurt me if I get it on my skin. That's why I'm wearing safety equipment. So, I've just put some of this strong acid into a glass jar. It's just a jam jar. And I'm going to see what happens when I put the seashells in. Let's see what it does to them. Wow, you can see it's already really fizzing. The acid is reacting with the chemicals in the seashell. And you can see it's doing a lot. Let's put some more in. Ooh. Look at those fizz. Looks like a fizzy jar of lemonade now. So I said we're going to be experimenting with rocks, but that was a seashell that I just put into the acid. The reason is, do you remember we talked about in the past how chalk and limestone are sedimentary rocks which are made up of the dead bodies of sea creatures? So things like chalk and limestone actually contain bits of shell and bones and skeletons of dead sea animals. So that's why I thought I'd first show you what happens to the seashells in acid. Now we're going to compare it to some chalk, some marble and some basalt. So here in our glass bowls is some basalt and some chalk. I'm going to pour some acid over them, see what happens. Let's have a look at what's happening here. So the chalk is really fizzing and bubbling. It's releasing a gas called carbon dioxide. That's because chalk is full of a chemical called carbonate, calcium carbonate. The acid releases that chemical and it comes out as a gas, carbon dioxide. That's the same gas that we breathe out. It's the same gas that comes out the back of diesel and petrol cars, and same gas which is in Coca-Cola or lemonade. The basalt though, we would have stopped fizzing now. No bubbles. That shows me that basalt has very little or no carbonate in it. The reason the chalk's got carbonate in it comes from the shells and the skeletons of the sea animals, because it's a sedimentary rock. So let's have a quick summary. Let's have a look. The seashells, they've been dissolved by the acid, turning into gas. The chalk, still being dissolved by the acid and turning into carbon dioxide gas, similar to the seashells. And the basalt from the volcano is not being affected by the acid at all. I just wanted to try one more little experiment. Found this rock in the garden. I've just given it a wash because it was covered in soil and dirt. I want to stick this into some acid and see what happens here. Oh, you can see straight away that that is really fizzing. Let's dip it all in, see what happens. That is super.
That is super fizzy. There must be a lot of calcium carbonate in this rock.